So this unit, or this chunk of the unit, is called sinusoidal functions. And the key to the word there is sine. So we're going to graph y equals sine x. Okay? So I'm not going to make you punch all this stuff into the calculator. We're just going to go with these predetermined values. So imagine this is a table. So this is your x, this is your y. Okay? So if x is 0, so what I did is on my calculator, I went sine 0. Okay? And I got out an answer of 0. And then I plugged in sine 30 and I got out an answer of 0.5. And then I plugged in sine 60 and I got out an answer of 0.866. So you don't need to know why those numbers are there. You don't really need to know where they come from. You just need to know that these are just points on a graph. X comma y. That's all they are. These are points. X comma y. That's all these are. So we're going to plot those points. So my x's here, and here's my y's. Now, we want to focus on scale. Do you see how there are 3 ticks to get to 90? That means that each tick counts for 30 degrees. So in other words, the scale is 30 degrees. Okay? Here is 1. There's 1, 2, 3, 4, 5. So that means each one of these counts for 0.2. So 0.2, 0.4, 0.6, 0.8, 1. Okay, so those are our scales. So what we're going to do is we're just going to plot these points. So 0, 0, 30, 0.5, 60, 0.86, 90, 1. No, my handwriting's atrocious. Does that make it better? A little bigger? Okay. Okay. So I'm right here, 120. So again, it's counting by 30s, right? So 90 plus 30 is 120. 0.86. This is 150. This is 120. Again, it's just counting by 30s. 0.5. And then 180 is 0. 210. So again, so now this is going to go down by negative 0.2s. Okay. So we've got 210 comma negative 0.5 right there. 240 comma negative 0.9. 270 comma negative 1. 300 is negative 0.9. 330 is negative 0.5, and 360 is 0. Okay, with a smooth curve, connect the dots. Swoop, swoop, like that. Oh, this is epic. Oh, that is good. Oh, tastes like strawberries. Normally, like sometimes, I shouldn't be talking about this. Anyway, sorry, I'm recording. Totally forgot. Edit button. Okay, so this is called a periodic function because technically, now we're not going to worry about this, but if I were to keep going, so if I were to go to 390 next, right, because I'm counting by 30s, if I were to go to 390, I could keep going. And what would happen is this pattern would continue forever and ever and ever. And same thing this way. The pattern would continue forever. So this is what we call a periodic function because this funky little wave, this little wave goes up, down, up. That pattern repeats, 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 repeats. Okay, I don't know if it's going to let me select this or not. Maybe it will. I can take this. Oh, it does. I can move it here. I can move it here. right? I can move it again back there. I can just keep moving it to get me the next chunk. That's what a periodic function is. It's just that pattern, repeat, 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 repeat. Okay? So I'll give you a second to catch up to plot those points. You don't need to know the points. You just need to know the shape. So essentially, all you need to know is you need to know that it starts at 0, 0, and it finishes at 360. The halfway point is 180, which means the halfway point again is 90, right? Halfway point, halfway point. At 90, it goes to 1. At 270, it goes to -1. That's all you need to know. And then you're just going to go swoop and draw it in. You don't need to know all these little points all along the way. Okay? The other picture that we need to know about is cosec's. Okay, so find page 367. I'm just going to do a little hopping and jumping around here. So cosec's is going to look almost identical to sin x. Okay? So I'm just going to tell you where the points go. I'm not going to bother filling in the table. I'm just going to tell you where the points are. Pretty much, just they're going to be shifted over. Yeah, so hit cos 0, cos 30, cos 60, cos 90, cos 2, right? Just, okay. So 0, 0 will have the point 1. Okay, so the scale is the same. Sorry, I should have said that. I'm very distracted right now. So we're using the exact same scale. And we're counting the same way. 30, 60, 90, 120, 150, 210, 240, 300, 330. Okay, using the exact same scale. Count by 30s, count by 0.2s. So the first point will be at 0, 1. The next point will be at 30, 0.9. Next point will be 60, 0.5. Next point will be 90, 0. We're going to repeat that now on the negative side. 120 will be negative 0.5. 150 will be negative 0.9. And 180 will be negative 1. Now I'm going to repeat again. 210 will be negative 0.9. 240 will be negative 0.5. 270 will be 0. Last repeat. 0.5, 0.9. At 360, you'll be at positive 1. It starts at the top instead of in the middle. Yep. So when you connect these ones, it looks like that. Now, same thing. This is called a periodic function because I can take this U shape and go here with it. Or I could take this U shape and I could go here with it. It just keeps repeating, repeating, repeating. So sine is a wave that repeats, repeats, repeats. Cos is a U that repeats, repeats, repeats. They all have the same commonality. They all start at 0. They all finish at 360. They all go up to 1 and down to -1. That's it. Okay? So, okay? Okay. So let's go back to this guy. I'm just going to shuffle my screens around a little bit here. Okay, why can't I do split screen? That's weird. Let me do dual. How interesting. Okay, that's kind of weird. Okay, so I don't know why it's doing that, but at the bottom of page 364, okay? The bottom of page 364. So I'm just going to draw out just the basic sine graph because this thing is not letting me have it side by side. So when I ask you to sketch the basic sine graph, that's all I want. You draw your wave in, 0 to 360, 1 to -1. Okay? Don't worry about plotting points. Now, this thing goes on forever and ever and ever. So the domain is x is real. Because it's going to, that wave pattern, remember, just repeats, 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 repeats. It's the Energizer Bunny. Never stops. The range. It has a bottom of -1 and a top of +1. Bottom of page 364. Yeah. Oh, I'm sorry. It's okay. Oh, yours is fill in the blank. Yes. Okay. Okay, so Melissa, you missed this. So yesterday we talked about the word period. It doesn't mean, right, it doesn't mean like period is in a punctuation mark. Period is the length of one pattern. Good on ya. Okay, so how long is one pattern? 360 degrees, right? From start to finish, the period's 360. Okay, y-intercept. Where do you cross the y-axis? At 0. Where were your x-intercepts? Well, they were at 0, 180, and 360. Okay, totally fine. Okay, so in the vid yesterday we talked about radians, right? Radians is just a different units for measurement, just like 1/2 and 0.5 different units for a number, okay? So for radians, still x is real. This is bottom of page, this is middle of page 365. Middle of page 365. Okay? Okay. So domain and range don't change whether you're talking about degrees units or radians use it. You use it as radian units, okay? Okay, those stay the same. Now, do you remember yesterday we talked about the equivalence, okay? What is the equivalent of 360 degrees? What is that in radians? Do you remember? 2 pi. Okay, so our period length is 2 pi. Okay, y-intercept is still 0. That has not changed. Now, our intercepts are at 0, 180, and 360. So if 360 is 2 pi, what is 180? 1 pi. So our intercepts are at 0, 1 pi, 2 pi. Now, I just need you to understand this. If you hit the pi button on your calculator, that is like saying 0, 3.14, and 6.28. Those are the x-intercepts. So in radians, okay, let me relate this to something that I hope you understand. 3 1/3 is like saying 10 over 3. 3 1/3 and 10 over 3 are the exact same thing. They both mean 3.3 repeating. Mixed fraction, improper fraction, okay? 1 pi, 2 pi is what we call exact radian. 3.14, 6.28 is what we call approximate radian because it's a decimal. So sometimes the diploma or test is going to want the exact number, in which case you give that guy. If it says approximate answer, you give that guy. Okay? And you'll know it's approximate because they'll say round to the nearest hundredth, which means 2 decimal places. Okay, let's do the same thing, but with this picture. Okay? So this picture was page 367. So I'm assuming right under it, because I didn't change the page number, we have this. Okay? So you have, for the coast graph looked like this. Started at 1, finished at 360. Whoops, don't do that. And halfway was down here at -1. So it's whoop, whoop, like that. Okay? Complete with sound effects. All right, so that's what coast looks like. So domain, remember it goes forever because that's the point. Range, same thing. Bottom, top. Right? Bottom to top. Period. Is the length of the repeat still 360 degrees? Yes. Now, here's what's different. Where's your y-intercept at? It's at 1. Sine was at 0, cos is at 1. Okay, x-intercepts. Okay, so these are our x-intercepts right here. So, what is halfway between 0 and 180? 90. What's halfway between 180 and 360? So those are your x-intercepts. Okay. Now, these are two pictures that need to be memorized. All you need to memorize is the start, the finish, the bottom, the top, then you just go swoop and draw on your shape. That's it. Sine, it's a wave. Cos is peak to peak. Okay. We did this yesterday, period and amplitude. So this was page 369. If you go to the second example on page 369, let's do it for these two pictures. So we've already talked about the period, but we have to go in and talk about the amplitude. Okay, so we already know the period. Now, you want to make sure that the units match. So you see how this is in radians? That means the period has to be in radians. So how long did it take for one pattern to happen? 2 pi. If you want to write the word radians in, you can, but you don't have to. Same thing here. How long did it take for one full pattern to happen? 2 pi. So whatever the units are on the x, your period has to be in the same units. 99.8% of the time, the units for the x-axis will be in radians. Okay, so you won't actually use degrees very often at all. Don't ask me why, because I don't feel like explaining it to you. It's just smile and nod. Okay. Okay, amplitude is half the total distance. So your total distance here is 2, right? From -1 to 1, the total distance there is 2. So half that is 1. Here, nope, just 1 unit. It's half the total distance. Yeah, it's to do with the y's. So here, again, total distance is 2. So half that is 1. Okay, visually, I'm going to draw amplitude on here because the visual is what's going to help you with this. I want you to take either different colored ink if you have a highlighter or whatever, and I want you to draw in the x-axis. And the reason why I want you to do that is no matter how smart you get, we learn through our eyes first. We learn through our eyes first, right? Like that's why you're hooked to your phone, your iPad, your whatever, your computer screen, because you're taking information in through your eyes. Visually, that's how most of us learn, right? Some people have to physically put their hands to it. Some people have to talk about it. Some people have to hear it. But at the end of the day, we take information in through our eyes, okay? When you draw in the x-axis, do you see how it visually chops the graph in half vertically? In other words, the amount of space here is the same as the amount of space here. Now, how much space is there? 1 unit, from 0 to 1. How much space is here? 1 unit, 0 to -1. How much space is here? 1 unit. How much space is here? 1 unit. How much space is there? 1 unit. That number is the amplitude. If you don't want to think of it as being half the total distance, visually, it's how high or how low the crests are. So how high is the hill? How low is the valley? That's what the amplitude is. I don't know if we have any stereo or music lovers in here, but when you turn up a speaker and you turn up the amps of the speaker, you're turning out the boom boom, right? Like the intensity of the sound. So the boom boom sound, like, so it's gonna hit harder and it's gonna hollow harder. You're changing the amplitude of the sound. That's why it's called an amp or an amplifier, because you're changing the high point and the low point of that sound. That's why it's called amp. Yep. We'll talk about that later. That's Monday. Yep. So what Kaylee was asking was, what if the x-axis is not the halfway point? Then what do I do? Well, that's Monday, Tuesday. Okay. Okay. So number one, page 373, is just having you try amplitude and period. So I'm going to give you a few minutes just to do that question. Okay. And then we will just continue on a few little things, then we'll call it good for the day. Okay, page 371, please and thank yous. And actually, I have this one copied for you because the one in the book isn't nearly this pretty. Okay. 3, 4, 4, and actually one more for Kaylee. So that's okay. I knew it was going to happen. And then Josh for you. And then this can be for Morgan. Okay, so even this is on page 371. It's not in color, so color is our friend. Okay, this is what we call the equation of a sinusoidal function. Okay? I just want you to focus on the fact that you see sine x. Okay? So, couple things with words. Y and x are called variables. They're called variables because they're always going to be there. Like when you hit y equals on your graphing calculator, you always have to hit an x to make it draw something, right? So y and x have to be there to create the equation. The a, b, c, and d, these are going to be numbers. Because they're placeholders, the fancy name for placeholders in math is parameters. So parameters are placeholders for numbers. Variables always stay as letters. Okay? So if you're currently going, oh, that's a lot of numbers. Okay, calm down. This is not Math 30-1. Okay? You are only responsible for 3 of the 4 numbers. You're going to be responsible for A, for B, and for D. Okay? Now, We have already covered the letter A. You just don't know it yet. A stands for amplitude. Very convenient. Amplitude is half the total height. Now, a couple important things with amplitude. First thing, half the total height. Secondly, it must be positive. When we say half the total height, the implication there is that it is a distance. So when you're driving in your car and you go in reverse, you are still covering a positive amount of distance. You're just doing it in a negative direction. Okay? So if you back out of a parking spot and you go back 5 meters, you've still covered 5 meters of space. Okay? It's just like if you were speeding in reverse and a cop pulls you over and says, hey, you were speeding, you were going 75 in a 50 zone. And you say, don't worry about it, officer, I was going backwards, it's negative 75. No, you're still covering positive distance at a positive speed, you're just doing it in a negative direction. Okay? Yeah, I'm sure they've heard it. Now, this is the fancy way of finding amplitude. Max means the top, min means the bottom. What these two lines here mean, it just means make the answer positive. It has a proper math name, but I'm not going to tell you what it is. Just make the answer positive. Now look, I'm not a big fan of formulas, especially when I have to memorize them, because that's not on your formula sheet. I would prefer you to think of it as half the total height. Visually, if we think of the sine graph, right? This right here, that's the A value. So you can either think of it as visually, find the peak and the valley, or take the total distance and divide it by 2. I wouldn't even worry about this stupid formula. It's not going to appear on a diploma. Okay? Period. This is the length of one cycle. So for sine and cosine, the length of the cycle was 360 degrees. Okay. So the letter B, so the B here is this B right here. That's why I highlighted it in blue. The letter B allows us to find the period. Okay. What I need you to understand is B does not equal period. B helps us find the period. B does not equal period. B helps us find the period. Now, there are two formulas. The first one is period equals 2 pi divided by B. Just into the bin, Jenna. Yep. The other formula is B equals 2 pi over period. What did I do in those two formulas? All I did was swap the B and the P. So do you need to have both formulas memorized? No, just know one of them and then swap. So if I give you the B value, you can find the period. If I give you the period, you can find the B value. So if I say B equals 3, That doesn't mean the period is 3. It means the period is 2 pi divided by 3. Okay? It's going to feel weird to you. This is theory for the sake of theory. Let me put it to you in degrees, just briefly. Let's say I give you an equation of, let's tell you I say b equals 2. Okay? 2 pi is the same as what degree number? 2 pi is the same as 360. So if I go 360 divided by 2, what's 360 divided by 2? So what that means is that if I use my sine graph and I go up, down, up, instead of it taking 360 degrees, it's only going to take 180 degrees. So if b equals 2, my period is now 180. The b value is not the period. The b value helps us find the period. And this is the hardest part of this unit, is this one tiny little annoying concept. It is a guaranteed diploma exam question, probably 2. So on the diploma, and we're going to do lots of examples. On the diploma, they're probably going to either give you the b value and ask you for the period, or give you the period and ask you for the b value. That's why it's probably 2 questions. Now, what we're going to practice is they could give you the explanation in words, they could give you a picture, or they could give you an equation. Either way, we need to be able to do these conversions. And once we've done a few of them, you're going to be like, oh, okay, yeah, this isn't that bad. Okay? But it just takes you a hot minute to get your brain around it. Okay? So, let's start with this. So on the next page, or at the bottom of the top of the next page, you should see this question. So it says, for the sinusoidal functions. Sinusoidal just means we've got like a sine x or a cos x. So, so the number in front, so this number right here, the number in front is the amplitude. The number in front is the amplitude. So this number right here, that is the amplitude. This is the amplitude. Now be careful here. The amplitude is positive 2, not negative 2. Just switch it. So why is that important? Because if this was a multiple choice question, amplitude equals negative 2 will be one of the choices. Yes, they will be that mean. On this one concept, they are nitpicky. The reason why is in order to get Math 30-2 accepted at universities, we had to throw in the trig unit and the rationals unit. The trig unit and the rationals unit are 2 tricky concepts. The trickiest part of the trig unit is this stuff today. So that's why we're going to review it fully on Monday. Like we're going to do 2 full days on this, right? So hopefully between those 2 days, you'll get it straight in your head. Okay, so this is the A, this is the B. This is A, this is B. Positive A, B. So the B is the number in front of the X. Okay? So the period, the formula is 2 pi over B. So the period is 2 pi divided by 3. Now you can leave it like that. This is what's called exact. If you punch this into your calculator, so if we go 2 pi divided by 3, you get 2.09. What x? No, because you're just putting the b value in. Yeah, yeah. So 2.09. Okay, now I'm going to draw a little sketch to show you what I mean here. So actually, let's just keep going, and then we'll come back and we'll look at the picture. So this one has the exact same b value. So again, period is 2 pi over 3, or about 2.09. For this one, now, again, use the positive version. Always use the positives of A and B. Don't use the negatives. So, on your calculator, you're expected to simplify this down. So on your calculator, don't hit the pi key. Don't hit the pi key. Go 2 divided by 0.25, and you will get out 8 pi. Yes. Okay. So this is called the exact answer. If you punch that in on your calculator, 8 times pi, you get out 25.13. Okay. So, didn't ask for this, but I'm going to make you do it anyway. Okay. Draw for me in the air what sine looks like. Up, down, up, right? It's a wave. Okay? So, our amplitude is 0.5. So what that means, it means the graph is going to go up to 0.5 and down to 0.5. It's going to go up, down, up. Because remember amplitude, I'm just going to do this in my erasable ink here. Amplitude, remember, is this distance. That's 0.5. Now, the period is the length of one pattern. So if you were to write it using exact numbers, you would say it goes from 0 to 2 pi over 3. If you wanted it as approximates, you would write 0 to 2.09. So that is how those numbers translate to the picture. So if we look at this guy, draw your sine in, swoop, right? Just draw it in. So what's my amplitude? 6. So it's going to go up to 6, and it's going to go down to 6. From start to finish, it's going to be 2 pi over 3, or if you wanted to use approximates, from 0 to 2.09. Now the last one, this is beyond Math 30-2, but I'm going to do it with you because I think you're super smart and I think you can handle it. Okay. That negative in front, remember how we ignored it? What the negative does is it flips your picture. So instead of going up, down, up, you're going to go down, up, down. That's all it does. It still goes 2 and 2. And from start to finish, it goes from 0 to 8 pi or 0 to 25.13. So that whole flippity-do thing, that is beyond 30-2. Okay? What we are doing is imagine us drawing in an imaginary box. We're going top, bottom, start, finish. And within that box, you go swoop, and you put your numbers on. That's all we're doing. Okay? So let that sink in. I'm going to stop here. Okay, I'm not going to show anymore. We will pick up at this point on Monday.